Now that we've validated our code using Terraform validate, and we've fixed all the errors, and now we are getting success, it's time to apply our setup. Make sure that we are using the right credentials under the current AWS profile. This is the profile we are using. Make sure you use your own profile, the one that you created for the user which we created while starting this tutorial. So once you've exported the right profile, and you validated with the success, it's time to run Terraform apply to create our resources. Once everything has been planned, it will show you the changes that are going to be done. We are going to add 43 resources. We are going to change 0, and we are going to destroy 0. Then you can review the modules. And for this case, we are using the code editor terminal, which might be limited in the amount of output it can show, like this one. So if you can modify the terminal settings to allow you to show more output, you can do that. But once you're satisfied with the plan, you can just key in the value yes. If you key in anything else, it will drop the apply. This is going to take a while because we are going to create the VPC first, and then after that we'll create the EKS dependencies, that's the roles. Then after that we'll create the cluster, and then we'll create the add-ons. After that we'll create the profiles, and after that we can test. So I'll skip some parts just to jump forward for the creation logs. Yeah, the cluster has finished creating. Now we need to create the other things that are dependent on the cluster. So now the profiles are creating. Profiles have finished creating. Now we are we're installing the add-ons. Everything has been created, and if you don't get any errors, this is the kind of output you'll get, and our cluster is ready. You can see the name right here, and then you can see the region. You can also get the OIDC provider here. We just obtained the ID because it's required somewhere else. That's why we obtained the OIDC ID here. So when you copy this ID and you come to data.tf under the load balancer role trust policy, we are using this OIDC ID to allow the OIDC provider as one of the federated principals to assume this role with the web identity. Then I just decided to put it here so that I can cross-check it while setting up the additional load balancer controller configurations that we'll be doing manually. Then we also needed the ARN for the load balancer role and also the name. So you can output only the ARN because it will give you the name also at the end here. And then you also need the VPC ID. So with this information here, we can go ahead and fill up some of this information in our values.yaml file for the load balancer controller. It's right here under the LB subfolder. So we'll just open the file and close other files. Within this file, we'll start with the first variable, that's the VPC ID. Just copy the one from the outputs. Then under VPC ID, make sure you input the right one. Then for your region, make sure you use the correct region. For my region, I used US West 2. For yours, use your own specific region here. For the cluster name, it's right here at the top, EKS cluster name. So just copy it and paste it here. Then we'll need the role ARN for the service account that will be used by the load balancer controller. The load balancer controller will be assuming this role for it to be able to create the elastic load balancer and also to create the target groups and connect them to your applications running on the private subnets in Fargate. For the role ARN, it's right here. So just copy it from this output, paste it here. And for the name, you can leave it as empty so that Helm can use the default service account name. And that's it for the values.yaml file. Before we can install the load balancer controller, we need to make sure we have a valid OIDC provider within our IAM console that this cluster can use. So just copy this URL and save it somewhere. We're going to use it in the console to create the OIDC provider for our cluster.